Section 7.4 is on solving logarithmic equations and inequalities. A logarithmic equation is an equation with one or more logarithms. If there's only one logarithm, then to solve it, we're going to write it in exponential form. And I have three examples for us to take a look at here. Actually, before we solve any of these, let's take a look at each problem. Notice here, x is my big number, okay, right after the base. In number 2, x is what the log is equal to. And in number 3, the base is the x. So we have the x in all three possible places. So let's write each of these in exponential form and then solve it here. So log base 81 of x equals 3/4 means 81 to the 3/4. I guess I don't need to do parentheses, but 81 to the 3/4 power. Okay, that's equal to, I'm going to write it with a smaller base. 81 is 3 to the 4th power to the 3/4 power. Multiply your exponents. That gives you 3 to the 3rd power, which is equal to 27. So in this case, x equals 27. Log base 81 of 27 is 3/4 because 81 to the 3/4 power is 27. Example number 2 here is a little more straightforward. Log base 8 of 1/2 equals x, or 8 to the x equals 1/2. Let's go ahead and write both sides with a base of 2. So that's 2 to the 3rd raised to the power of x is equal to 2 to the negative 1. I guess I don't have to have parentheses on that. 2 to the negative 1. Multiplying over here, that's going to give me, actually maybe I'll move it up here, 2 to the 3x equals 2 to the negative 1. Pulling off the exponent, 3x equals negative 1, or x equals negative 1/3. So looking back at my original equation, log base 8 of 1/2 equals a negative 1/3 because 8 to the negative 1/3 power equals 1/2. And here we have log base x of 32 equals 5/2. Writing that in exponential form, x to the 5/2 power equals 32. Couple different ways I could solve this. Maybe what I'll do is write, go ahead and square both sides. That would give me x to the 5th equals 32 squared. Now if I want to get that to a 1, I can raise both sides to the 1/5 power. So that's going to give me x equals 32 to the 2/5. You can plug that into your calculator, or let's take that a step further. Let's write 32 with a base of 2. 32 is 2 to the 5th to the 2/5 power. Multiplying the exponents, that gives me x squared, or 4. So log base 4 of 32 is equal to 5/2. So just use a lot of the rules that we've had before to solve those. Now, taking a look at some logarithmic equations, if b is a positive number greater than 1 and log base b of x equals log base b of y, then x equals y. So in other words, if you have the same base for your logs, you can just pull off what you're taking the log of and set those equal to each other. So here I have log base 3 of x squared minus 15 equals log base 3 of 2x. So I can just write that as x squared minus 15 equals 2x. And I realize this is a quadratic equation because it has an x squared. So to solve that, I'm going to set it equal to 0. So subtracting 2x on each side. Let's factor that. That's going to give me x minus 5 times x plus 3 equals 0, or x equals 5 and x equals negative 3. And since you can't take the log of something negative, x cannot equal negative 3, so x is equal to 5. Now for inequalities, yeah, that's right, I'm sorry. Okay, for inequalities, we have a couple rules here. So if there's only one log in the inequality, if log base b of x is greater than y, and here we have if log base b of x is less than y. This is a little confusing. You might want to just kind of write it in exponential form, and that is say b to the y is greater than x, but it's actually the other way around. The x stays in place. So if log base b of x is greater than y, then x is greater than b to the y. So leave the x there, move the b over, and make that the base raised to the power of y. Now with a less than, if log base b of x is less than y, then x has to be a number between 0 and b to the y. Okay, because x cannot be a negative number, so it has to be greater than 0, and then the x is less than b to the y. And that's for values of b greater than 1 and x greater than 0. Now, if you have a log on both sides, it's a little bit easier. So if log base b of x is greater than log base b of y, then just x is greater than y. If log base b of x is less than log base b of y, then x is less than y. And again, b is greater than 1, and x and y, what you're taking the log of, have to be positive. They have to be greater than 0. So let's take a look at a couple examples here. So here I have one where I just have one logarithm in it, one inequality with one logarithm. So log base 3 of x is greater than 4, so that's going to give me x is greater than or equal to 3 to the negative 4, and 3 to the negative 4 power is 1 over 81. Notice again, I didn't write it in kind of standard exponential form. I left the x where it is, left the inequality symbol the same, moved the base over and raised it to this power here. Going to do the same thing over here, so I have log base 6 of x is less than negative 3, so I'm going to leave the x there and say that's less than 6 to the negative 3 power, but x has to be greater than 0, so I need to throw that in as well. So 0 is less than x, which is less than 6 to the third power is 216, so 6 to the negative third power is 1 over 216. So if there's one logarithm, leave the base where it is, and if it's a less than, your x value is going to have to be greater than 0. Let's take a look at a couple examples where we have a log on both sides. So here we have log base 2 of 4x minus 6 is greater than log base 2 of 2x plus 8. So since I have a log on both sides, the same base, I can just pull off what I'm taking the log of. And so 4x minus 6 is greater than 2x plus 8, or 2x is greater than 14, or x is greater than 7. And in this case, I don't really have to worry about anything being negative because x is always going to be a positive number. It's going to be greater than 7. Okay, last example here, log base 5 of 2x plus 1 is less than log base 5 of 4x plus 4. Again, I have the same base, so I can just pull off what I'm taking the log of. Oops. And solving that is going to give me x is less than 3. But x has to be, or actually not so much x, but in this case, what's in what I'm taking the log of has to be greater than 0. So I have to set each of those to be greater than 0. So 2x plus 1 has to be greater than 0, and x plus 4 has to be greater than 0. So this is going to give me x has to be greater than a negative 1/2, and x has to be greater than negative 4. So I have to make sense of all of these inequalities here. For me, the best way that I do it is to look at it on a number line. So here's negative 4, negative 1/2, and 3. Oops. Let's make that a little neater. So x has to be less than 3. So that has to be a part of my answer. But it can't be such a small number that's going to make the stuff in the parentheses 0 or smaller. X has to be greater than a negative 1/2, and x has to be greater than a negative 4. So where do all three of those graphs overlap each other? And that is in this region right here. So negative 1, I'm sorry, negative 1/2 is less than x, which is less than or equal to 3. And that's my final answer. So that's going to both solve this inequality and keep the value, the expression that I'm taking the logarithm of, greater than 0. So in this section, we took a look at how to solve logarithmic equations and inequalities, those equations and inequalities that have just one log in them, and then equations and inequalities that have two logs in them.